Imagine building something not for your kids or even your great-great-grandkids, but for some futuristic descendants who might be half human, half cyborg, and allergic to gluten. That's exactly what Sweden is doing, digging a billion-dollar hole in the earth, deeper than your existential dread at 3 a.m., and tucking nuclear waste into bedrock that's older than dinosaurs. No, it's not a Bond villain's secret lair or an evil lair starter kit. It's the Forsmark spent fuel repository. Think of it as humanity's ultimate do not open until forever time capsule. Welcome to the world's most expensive game of radioactive hide and seek, the unsolved nuclear problem. Since the 1950s, nuclear energy has lit up our cities and powered our gadgets, quietly supplying about 10% of the world's electricity from over 400 reactors, clean, efficient, and about as carbon-friendly as a tree hugger on a solar panel. But hidden behind the glow is a glowing problem: radioactive waste. We've cracked nuclear fission, sent robots to Mars, but still haven't figured out where to safely stash the leftover nuclear soup. Waste comes in 3 radioactive flavors: low-level stuff like contaminated gloves and lab gear, basically nuclear laundry; intermediate level waste like reactor parts, spicier but manageable; and the real diva, high level waste. This last 1% is like that one guest who refuses to leave for hundreds of thousands of years and needs an underground bunker, climate control, and 24/7 supervision. It's hot, dangerous, and basically immortal, and despite decades of innovation, humanity is still playing radioactive hot potato with it. Why is high-level waste such a threat? After fuel rods have completed their life cycle inside a reactor, they remain extremely radioactive and continue to generate heat. Initially, they're submerged in deep pools of water at nuclear plants. Water acts as a coolant and a radiation shield. After a few years, they're transferred to dry cask storage, thick containers made of steel and concrete designed to isolate the waste. These methods work, for now, but both require ongoing maintenance and human oversight, sometimes for decades or centuries. Any power outage or equipment failure could risk a meltdown, like what occurred in Fukushima, Japan in 2011. That disaster was triggered when cooling systems failed, leading to explosions and the release of radioactive material into the environment. We need a solution that works without electricity, without monitoring, and ideally, without humans at all. Forsmark, Sweden's answer to the nuclear dilemma. Enter Forsmark, a coastal site already home to one of Sweden's nuclear power plants. Adjacent to it, engineers have broken ground on what will become one of the first permanent deep geological repositories for nuclear waste in the world. The only other comparable project is Finland's Onkalo repository, which uses similar methods. The goal? To safely store all of Sweden's spent nuclear fuel for the next 100,000 years. Let that sink in. 100,000 years. When humans were just beginning to migrate out of Africa, before the invention of writing, the wheel, or the pyramids. That's the time frame this facility is expected to endure. Why Forsmark? Why Forsmark, you ask? Because if you're going to bury radioactive material for 100,000 years, you don't pick a spot that likes to shake, crack, or shift like a teenager's mood. Forsmark's bedrock is the strong, silent type, nearly 2 billion years old and stable as a rock star grandparent with barely a fracture in sight. It's like nature's own vault, tailor-made for deep, undisturbed storage. Even better, it's right next to Sweden's Forsmark nuclear power plant and the SFR facility for lower-level waste, meaning no need for hazardous waste road trips. Everything nuclear, all in one neat little radioactive neighborhood. It's the IKEA of nuclear storage. Simple, practical, and everything's in one box. A look inside, what the repository will become. Above ground, the site is modest: offices, support buildings, and piles of excavated rock. Below ground, however, it's a marvel of engineering. A 5-kilometer ramp will descend deep beneath the surface, where it branches into a sprawling network of tunnels, eventually stretching 66 kilometers across a 3 to 4 square kilometer area. These tunnels will house 6,000 copper canisters, each filled with about 2 tons of high-level nuclear waste. The repository is designed to hold all spent fuel currently in temporary storage, and any waste produced in the coming decades. Timeline and cost. The idea for this facility was first proposed by SKB, Swedish Nuclear Fuel and Waste Management Company, back in 2009. After years of planning, review, and debate, the project received final approval in 2024, and construction began in early 2025. The initial budget is just over $1 billion USD, with the first spent fuel canisters expected to be placed around the late 2030s. Full completion, including all excavation and canister placements, isn't projected until 2080. Yes, this this project will span over half a century, because that's what it takes to bury danger for 100,000 years. The technology, KBS-3 method. Sweden's secret weapon against radioactive chaos is something called KBS-3, a 3-layered, ultra-secure burrito wrap for nuclear waste that's more fortified than a medieval castle. First, the spent fuel takes a decades-long spa retreat at Clab, cooling off for 30 to 40 years until it's less spicy. Then comes its forever home, a 5-meter-long copper canister that's tougher than your grandma's fruitcake, with a cast iron insert snugly hugging the fuel. These are sealed shut using friction stir welding, basically a metal massage that fuses everything tight. Next, the canister is tucked into a vertical bedrock hole and lovingly packed in bentonite clay, which swells up like it's got stage fright whenever water appears, keeping the bad stuff locked in. Think of it as nuclear Tupperware with a cat litter lining. Finally, everything gets buried beneath 500 meters of ancient rock, far from humans, squirrels, and nosy archaeologists. The tunnels are sealed tighter than Area 51, ensuring no radioactive sneak outs. It's like locking up your worst ex and throwing away the key in bedrock. Safety concerns and potential challenges. Of course, even a plan this detailed isn't without controversy. Some researchers from Sweden's Royal Institute of Technology have raised concerns about the long-term corrosion resistance of the copper canisters. If the canisters deteriorate faster than expected, radioactive material could eventually escape. Environmental NGOs have also called for more rigorous safety assessments. One group even filed a court appeal, which could delay the project further. However, construction is moving ahead with the goal of staying on schedule. What happens when it's all over? When the last copper canister is tucked in, the tunnels sealed, and the final "Do Not Disturb" sign metaphorically posted, Sweden's Forsmark repository will quietly vanish from the surface of the Earth. No museums, no glowing caution signs, not even a plaque saying radioactive stuff buried here. The above-ground buildings will be razed, the land returned to nature, and the whole operation will fade into myth. Like Atlantis, but with way more paperwork. Why all the secrecy? Because in this case, ignorance truly is bliss. The goal is to make it so boring and unremarkable that future civilizations or intergalactic tourists don't get curious and start digging. After all, if you discovered a mysterious unmarked site, would your first instinct be to open it or run away screaming? Sweden's betting on the latter. A radical, necessary step forward. The Forsmark project represents a turning point in how humanity deals with the toxic legacy of its most powerful energy source. For the first time, we're building a system that doesn't just store nuclear waste, it contains it, isolates it, and forgets it. For 70 years, nuclear power has illuminated our cities and powered industries. And yet, until now, there was no true permanent solution to the waste it left behind. Sweden is setting a precedent that other nations will need to follow if nuclear energy is to have a sustainable future. Should we still use nuclear power? This project naturally raises a broader question. If it takes this much effort and this many centuries to manage waste, should we still be using nuclear power at all? That's the debate between those who see nuclear as essential to combating climate change and those who argue the risks are too great, the costs too high, and the solutions too slow. But there's no doubt that until renewables can fully meet global demand, nuclear energy remains a crucial part of the energy mix, and if we're gonna keep using it, we owe it to future generations to clean up after ourselves. If you enjoyed this deep dive into humanity's ultimate game of radioactive hide and seek, hit that like button so the algorithm doesn't bury us like nuclear waste. Subscribe for more mind-blowing science stories that last longer than copper canisters, and drop a comment. Would you open a 100,000-year-old mystery vault?